Mr. Meyer, what is a mole? A mole is an animal that burrows in the ground, or the spot on your chin that you gotta shave around. But a mole is a number, can't you see? That we'll use in chemistry. A mole is a number. Haven't you heard? It's 6 times 10 to the 23rd. That's 6 with 23 zeros at the end. Much too big a number to comprehend. So let's say I had a mole of iron. How big would that be? Well, this is a mole of iron right here. Let's say I had a mole of sulfur atoms. How big would that be? This is a mole of sulfur atoms right here. A mole of silicon atoms right here. A mole of zinc atoms right here. A mole of aluminum atoms right here. A mole of sodium chloride molecules, or technically formula units right here. A mole of calcium carbonate molecules or formula units right here. A mole of water molecules and a little food coloring right here, and a mole of ethanol and a little food coloring right here. And here is a mole of sucrose, which would be table sugar right here. And if I had a gas and it was at standard temperature pressure, which is pretty close to room conditions here, it would actually take up a volume of 22.4 liters, like this big 22.4 liter cube right here. All right, so that is a mole. And just like how many are in a pair, if I have a pair of aces, I have 2 aces. If I have a dozen, looks like styrofoam balls, I have 12 styrofoam balls. And if I have a mole of iron atoms, I have 6 times 10 to the 23rd iron atoms, or not 600, not 600,000, not 600 million, not 600 billion, not 600 trillion, well, you get it, a really, really big number. So a couple questions here. What did I do to get 6 times 10 to the 23rd atoms of iron in here, and sulfur in here, and so on? How did I measure that out? How did I figure that out? And then the second thing is, if there are 6 times 10 to the 23rd atoms of iron here, what does that tell us about the size of each individual atom? All right, we are going to go to a screen share and look at some of these things. So I'm going to grab this here and try this, move this around. And if you went to your homework packet, I think it's page 3, there are a few notes about moles. And one is a mole is a number used in chemistry, and that number is 6 times 10 to the 23rd. So just like a pair is 2, a dozen is 12, a mole is 6 times 10 to the 23rd. If we're a little bit more precise with it, we could actually say 6.022 times 10 to the 23rd. We probably have it figured out to about maybe 8 figures right now, but that is 6 times 10 to the 23rd, or 6.02 times 10 to the 23rd is going to work well for us. Each element may have a different sized atoms. So all these elements in the background here might be different sizes or amounts, especially when we got to the molecules of sucrose. We saw that that was taking up a lot more space than, let's say, the iron right here. So, okay, because of different sizes, each element has a different mass for 6 times 10 to the 23rd. It's just like if I took these 12 styrofoam balls here, they're going to weigh more than this package of 12 smaller size styrofoam balls right here. So one is bigger, one is smaller. And if I had 12 eggs, that dozen eggs is probably going to weigh more than either one of these packages right here. Well, again, atoms have different masses, and we end up calling those molar mass. Molar mass of an element is equal to the atomic mass on the periodic table. So if I wanted to find the molar mass of helium, I would just look at my periodic table, okay, and I scrolled right past it, and I think I'm hiding it on mine. It's way up in this corner here. I see helium. Now, this 2 right here, a little bit hard to see, is the number of protons and electrons. This 4 here is the protons plus the neutrons but it's a weighted average of the isotopes. So we use this decimal figure. Typically, I'm going to ask you to just round things to the nearest tenth right here. So I'm going to say 4.0 grams would be the mass of 1 mole of helium atoms. What would 1 helium atom weigh? It would be 4 atomic mass units. But 1 mole, or 6 times 10 to the 23rd atoms of helium, would weigh 4 grams. And that's something more tangible, something we can think about more readily. All right, so I'm going back to an example. I think it talks about H2O. So I'm just going to go here. What if I have this molecule of H2O? Okay, I'm going to try to figure out what the mass of, I'm going to look at this H2O and try to figure out what the molar mass of this is. Well, H2O, I have 1 oxygen, and that's 15.999. I'm going to round that to 16.0. And hydrogen, is hydrogen hiding on the other side? I think so. Hydrogen is 1.0079. I'm going to round that to 1.0 grams in a mole, but I have 2 of them. So I'm going to add up 16 for the 1 oxygen plus 1 for the 2 hydrogens. 16 plus 1 would be 18. That would be the molar mass of a compound. Let's go back to our page, which shows that, and make sure that makes sense to us. So again, I look at the periodic table, I see hydrogen is 1, but I have 2 of them. 2 times 1 is 2. I have 1 oxygen, that's not a 0. That's an O for oxygen. 1 times 16 would be 16. 16 plus 2 would be 18, or 18 grams per mole. So let's just go back to this question. Did I sit here and count all these things out? Okay, I don't have much of a life, but I probably have a little bit more of a life than that. No, okay, I wasn't counting those pieces. In fact, it would take pretty much infinitely long to count something like that out. I weighed it out. So I weighed out 18 grams using a balance for H2O. If I were doing helium, if I had that gas, I would weigh out 4 grams to figure out what 1 mole is. So that is how I figured things out. The other question is, let's say I have a mole of water molecules here. Okay, if I have 6 times 10 to the 23rd, or 6 kabillion, jillion, whatever that number is, okay, what does it tell me about the size of each molecule of water like this? There's so many in there. It's got to be really, 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 really small. So those are some of our fundamental questions that we have. All right, let's get to work and look at a couple problems and just solve this. So I'm going to look at finding the molar mass of some different elements. One is iron and one is carbon. I'm going to kind of do a 2 for 1 and kind of scroll to that table. So if I'm doing iron, I look through my table and find that, ironically, it's in this transition metal row, and it is number 26, but that's not the mass. A little bit hard to see here, but it looks like 55.845. And I think in my assignment, I said round to the nearest tenth. So you could say 55.8 grams per mole of iron. If I were doing copper or carbon, it would be the same thing. I'd round 12.011 to 12 grams, right there at 12.0 grams. So I'm going to go in and just write these answers in here. And let's see, and I just looked that up directly for an element on the periodic table. So I'm going to say 55.8. I think I'm going to do it like this. Be quicker. I'll say 55.8. And I'm going to go grams. The unit is grams per mole. Now, the craziest abbreviation is mole. It's MOL instead of MOLE. Doesn't give you a lot of help, but it's ingrained, and that's what I'm going to use. And then the carbon would be 12.0, and that would be grams per MOL right there. So that is finding the molar mass. If I have 1 mole, or 6 times 10 to the 23rd iron atoms, it's going to weigh 55.8 grams. If I wanted to measure that out, I would just put this on the balance, put the thing on the balance, hit the 0 button, then add 55.8 grams. All right, let's just scroll down. You get, like, I think a number of these molar mass problems. Let's just look at one or two more. Let's say you get something like NH3 in number 9. All right, I could go to my periodic table and look up N. I'm going to scroll there, and N weighs, looks like 14.0, and I think we established hydrogen was 1.0. So if I were doing that one, I'm going to clear my drawings here. I'm going to come back and let's see. If I were doing this, I might say, I think I'll go to a text, I might say N, and I might say 1 times 14.0 equals 14.0. And then I'm going to try to do hydrogens, but notice for hydrogen, I have 3 of them. So I'm going to say hydrogen, try to line that up, 3 times 1.0 is going to equal, and what's the 1.0? That's the grams per mole of hydrogen. That's going to be 3.0. And then what do I do with everything? The 14 and the 3, I add those up, and my answer is going to be 17.0 grams per MOL. So we might call this nitrogen trihydride, but the more common name is ammonia, and that would be 17.0 grams per mole. I think I'll do one more example of a problem. All right, and it has to do with, let's scroll down there and find it. It's on the next page. It is aluminum carbonate. Okay, so I got Al, C, and O. Let's look up our elements. And we got aluminum coming in at 26.98. I don't round that to 26, I round it to 27 or 27.0. Carbonate is a C, which is 12.0. And oxygen, I think, is going to be 15.999, which is 16.0. So these are all kind of nice. They're ending in zeros. Makes the math a little easier. This is where you want to be careful. So I'm going to do this right here. I'm going to talk first about aluminum. And I have 2 times, I think we said that was 27.0. So I'm going to say 2 times 27.0, which equals 54.0. The next one I'm going to do is carbon. So I'm going to say carbon, and then I'm going to say 3 times 12.0 equals 36.0. And the reason I did 3, if I look at this, is I have 3 groups of CO3. So I have CO3 3 times, which means I have 3 carbons, and I have 3 times 3, or 9 oxygens, not 3 plus 3, 3 times 3, which would be 9 oxygens. So that's going to be my last piece I'm going to do, and I'm going to put O. You'll probably see on my key, a lot of times I put O in the quote because it looks like a 0. And I'm going to say that's going to be 9 times 16.0, which equals, let's see, 10 times 16 is 160, minus 16, I think 144. And what do I have? 144 plus 36 plus 54. And I think this is going to be right. Let's try this. I'm going to say 234 grams per mole right there. So this page is just polar masses. Notice some of them you're going to have to find the right formula. Have to think back about how you knew formulas to solve these. And I think that gives you good practice at working with that. All right, that is molar masses. At the end of this page, there's just a little review of scientific notation because we're going to get that there. And if you look on your homework packet, you'll see kind of numbers and a key, partial key that's posted. Thank you for joining.